Welcome back, dear students. I am Rajiv Lohani and I am discussing with you the topic electrostatics. In the previous video, I discussed some terms like electric dipole and electric dipole moment. Today, I will try to find out the electric field of a dipole at a point number 1 on its axis and number 2 on its equatorial plane, as I have mentioned earlier. For that, we will take a dipole AB with length AB equal to 2L, and let us assume that at A is situated the charge plus Q and at B is situated minus Q. Suppose O is the midpoint of the dipole. So OA will be equal to OB equal to L. Now suppose there is a point on the axis of the dipole at a distance r from its midpoint. Call this point P. This is the point at which we have to calculate the electric field due to the given dipole. We can see from the figure that the distance of minus Q from P is BP, which is equal to R minus L, and the distance of plus Q from P is R plus L, that is AP is R plus L. Now suppose that because of the charge plus Q, the electric field at this point P is E1. So E1 will be directed away from the charge as shown in this diagram. And the magnitude of E1 will be equal to E1 equal to 1 upon 4 pi epsilon 0 into Q upon R plus L. In the same way, the magnitude of, if the electric field due to the charge minus Q is E2, then E2 will be directed towards the charge and its magnitude will be E2 equal to 1 upon 4 pi epsilon 0 Q upon R minus L whole square. Since the two fields are opposite to each other, so we will get the resultant directly by getting the algebraic difference between the two fields. And we can see minus Q being closer to P as compared to plus Q, the magnitude of E2 will be greater than that of E1. So the resultant field can be written as E equal to E2 minus E1 directly, which is equal to, taking Q upon 4 pi epsilon 0 common, 1 Q upon 4 pi epsilon 0 into 1 upon R minus L whole square minus 1 upon R plus L whole square. This is equal to Q upon 4 pi epsilon 0 multiplied by, in the denominator we will have R square minus L square whole square as the LCM, and when we simplify the numerator we will get the term 4 into R into L here, which can be further written as E equal to 1 upon 4 pi epsilon 0 into 2 into 2QL into R upon r square minus l square whole square. Now we know that the product Q into 2L is called the dipole moment of the given dipole and is denoted by the letter P. So we get E equal to 1 upon 4 pi epsilon 0 into 2pr upon r square minus l square whole square. This is the desired expression for the electric field at a point on the axis of the dipole and at a distance r from its center. Now comes the direction of the electric field. You can see from this diagram that since in this case if I take P on the right side where minus Q is closer to the point P, then the magnitude of E2 will be greater than that of E1, so that the resultant field will be E2 minus E1, which will be in the direction as shown by this arrow. That is, it is directed from minus Q towards the plus Q. If I take the positive charge on, the point on this side, then the electric field due to the positive charge plus Q will be outwards E1, that due to the negative will be inwards, and E2 in magnitude in this case will be smaller than E1, so that the resultant field is again in the direction E1 minus E2, that is from minus Q to plus Q. Thus we can see that the electric field of an electric dipole at any point on its axis is along its dipole moment.